Hi everyone. Welcome to this lab on analyzing data with Apache Spark in Microsoft Fabric. Apache Spark is the engine that powers big data processing in Fabric. But what makes Spark so special? Think of Spark as a distributed computing framework that can process massive data sets by splitting work across multiple machines. So you're distributing. Unlike traditional database that runs on a single server, unless there are some conditions like cluster, Spark distributes your data and computations across a cluster, enabling it to handle terabytes or even petabytes of data efficiently. So, Spark works with data frames. Think of them as a supercharged tables that can be processed in parallel. You can filter, aggregate, join, and transform data just like you would in SQL or pandas. But Spark does it at scale across distributed nodes. In Fabric, Spark comes integrated with Notebook, which is the interactive environments where you write and execute code in real time. Notebook supports multiple languages, PySpark for Python developers, Scala for JVM, R for statistician, and even SQL for those who prefer declarative queries. So in this lab, we'll work with PySpark, Python optimized for Spark. You will start by uploading CSV files to your lakehouse and then load them into Spark data frames with a defined schema. Schemas are important here as they specify data types and ensure data quality from the start. So we learn to transform data using data frame operation, filtering rows, selecting columns, creating new calculated fields, and also aggregating results. We'll also see how Spark SQL lets us query data frames using familiar SQL syntax. A key concept we'll explore is also partitioning. When saving large data sets as Parquet files, you can partition by columns like year and month. This means Spark only reads the relevant files when you query specific time period. It's dramatically improving performance. We'll also discover how Spark bridges the gap between file-based data lakes and SQL-based data warehouses. By catering managed tables in the metastore, we'll make our data queryable through SQL while still maintaining as optimized Parquet or Delta files. Finally, we'll visualize our data using both Fabric's built-in charts and Python libraries like matplotlib and seaborn. Visualization is crucial for understanding pattern in your data quickly. The beauty of Spark in Fabric is that we don't need to manage infrastructure, no clusters to provision, no configuration to team, just write our code and Fabric handles the rest. Let's begin processing data at scale with Apache Spark. Do analyze data with Apache Spark in Fabric. So what we are going to do, we are going to actually ingest data into the Fabric Lakehouse and use PySpark to read and analyze the data. So let's start the lab. So very first thing, we have to create a workspace. Let's create a workspace. new workspace, and give a name, workspace name. So let data fabric workspace 02. Then under advanced, make sure that fabric capacity is enabled. Click apply. So workspace has been created. So now we are going to create a lake house under here. So new item, search for lake house. So go here, click lake house, give a name. So data fabric lake house 02, and click on create. As I mentioned previous lab, that you can also go this three dot button, then you can go from here also to create that lake house. And you see that after creating lake house, that it's actually enabled under Explorer. You can see that you can browse tables and files inside that lake house. So now the lab file, I'll give you the GitHub link and Microsoft log in the description section, so that you can use that one for this lab. To ingest data, we got this zip file that we are going to use. Go there and let me unzip that file. That is fine. Now go back when that is unzipping. Here under the files folder, we're going to update that. Some files, then upload. We can do files also folder. We can go straight folder because we are uploading all three files together. So three files has been uploaded. You can check that from here also. That three files has been uploaded. So now we are going to create a notebook. So for that we can go back to that workspace. Under that workspace, you can just create a new item. Search for notebook. And it's not get data notebook. We are going to use that one. So click that notebook and then give a notebook name. Is there any name requirement here? Okay, data fabric book 01. Click on create. So when you create the notebook, here is this notebook selected, and it just open a notebook like if you are familiar with the like Jupyter notebooks, so it's similar like all the cloud provider has got like notebook setup, so similar to Jupyter notebook. So here the similar way here is that it's coming as a comment section, but as a code block. If you want to change it to like as a markdown, then you can use this marked M button. So it will convert to code to markdown section. You can edit that one. And then click outside of that one, so it is coming as a markdown window. Now we are going to create a data frame. We have created workspace, we have created a lake house and also a notebook. So now we are ready to work with the data. So we are going to use PySpark, which is the default language for Fabric notebook, and the version of Python that is optimized also for Spark. So now if we go to that workspace here, you can see under that workspace that data lakehouse is there. Then you can also see that notebook is there, so you can see all those items. Now if we go to lake house, and you can see that there is a order like the order folder. So from that we are going to use this one. For that, you see that open notebook, click on open notebook and existing notebook that we are going to use. And the notebook we created, we can select because right now there is only one. So we are going to select that one and click on open. So now see that notebook is open here. And if we expand that lake house under files, you see that order folder, and if we select the order folder, so you can see those files under order folders are here, all those CSV files. From this now 2019 CSV file, that three dot you see, select here load data and into Spark. So if we click that one, you see that it has got a code block or code cell automatically generated here. And for anything to hide, you can just collapse that one. So now to run that cell, just click on this run cell. And first time it may take little more time compared to second one because it's getting the data from the source itself, not in buffer or memory at all. So here you see the output we have got based on that 2019 CSV displayed in the column and rows. That the column header, if you look here, header columns has got actually not the header like column name, but it has got some kind of data there. So we need to correct that one. To do that, let's get another code block and execute the query here, like execute this. So when you've done that one, if we execute this code again, we cannot see, not change it. So let me check the code again. I missed that one. I did. Let me just state change here. Instead of true, we can just put false here and then display the value. So if we execute this one, running. So now here you see it has changed the header. So last time it was getting the wrong entry, but this time it is getting like it's a little bit different format like C0, C1, C2, C3. So now we want because that is not the proper name, so we want a like a meaningful name. So therefore we are going to modify the code as below. So let's go a new code block and execute this one. Here you see that we are giving the name like field name. So let's execute. So we are getting data only for 2019. And if you look here, this time it's actually getting the right column name. Now, if you would like to get not only 2019, we want everything. So we can modify the code to reflect the change here, that in while string, that search string, so that last time we are just only getting 2019. We can get that for like all the sales related to 2019, 2020 and 21. So we can, yeah, it's a subset of data, but we can see the informations. So here is the option is there, we can clear output, hide output, or we can resize also if you select this button. So now we are going to explore data in a data frame. So what is data frame? Data frame objects actually provides some additional functionality such as like ability to filter, filtering data, then grouping data or different manipulation of data. So let's do some more on data frame. So click on code. So here we are creating a data frame. It's a data frame called customer, which contains this like subset columns like customer name and email that we are going to use. And also we are going to get the value of count, and we can see the distinct count number and then display the distinct customer. So similar result, similar output, we can use alternate scope. By running this query. Now we're going to add a where clause so that we can filter data. So here we are getting for an item and specific this item row 258 and 52. So here we can see the customer like who have actually purchased those two items. So for that we have used where clause. Now let's do some aggregate and group data in data frame. So here we are using group by based on sum of item. So if you see the output, it is showing that sum of order quantities based on product. So this group by use that one to do that one. Let's do another code. So here what we are doing, we are just using input statement that enables like to use Spark SQL library that we are doing that one. Then select method is selecting is used with SQL here, like SQL here function to extract the here component of the order date. It's making that as an alias here. It will come as an alias, and group by also based on here column. Here you see, and then it's coming count. So count of rows in each group calculated before order by. So there is a sequence, you can see that one. So select, we are using an alias, then we will use group by and followed that order by. So let's execute that one. So far we have just so many like Spark, we can query the data, how we can aggregate the data and different um, like query related data. Now we are going to use Spark to transform data files. So one common task for data engineers and data scientists is to transform data for further downstream processing for analysis. So here we are going to create year and month column. Then we are going to create first name and last name field, but we are splitting that one. And then we are filter and reorder columns like based on these three columns. Of the columns we are just filtering and order them, so one after another we can see that field and then display that one. So let's execute the cell. So here you see that it's created a data frame, and if you look here we can see year, month, first name and last name is separated. So you can review the output and you can modify the query based on your requirement. So you can use the Spark library to transform the data by filtering rows, or that you can deriving, you can removing, renaming columns, and applying other type of data modifications. Now we'd like to see, like sometimes we may need to save the transform data. So we would like to save the data. So for that, like uh, we know that Parquet is a popular data storage format because it stores data in efficiently and it's supported by most large scale data analytics systems. So let's execute a code, and you can see all every PySpark. Still we can see that PySpark that we are running. So here we are transforming writing, overwrite, and Parquet format that the data is getting from there under files transform data. So it will create a transform data under files folder. So if you look here right now, you cannot see that there is a transform data. So let's execute that one. Job is executing. It has been done. It's a transform data saved. So message is there. Now if we refresh, and we can see that transform data folder is there, and if we click that we can see that there is a new folder named order, and if we click that, let's say view files, refresh, and just check there. cannot see options there. New subfolder upload there. So expand the orders here, that expand that one, and you can see that there are order data has been loaded from the Parquet files here. Now we are going to save data into partitions files. When there is a heaps of data, then partition can help you to query the data very quickly. So we are doing partition based on year and month. Mode is override. Parquet files, we are giving that the transform data, and we would like to get a message that transform data set. So execute that one. We got a error message. Let me find out. Orders under DF is not defined. Let me find out what the problem here. Just transform, I think it's not getting the data, so let me save it here. I think we missed one step. We did not save the transform data set, but we did not see the data. So let's display that here after saving the data. Let me display that data just to make sure that we can see. So here we can see the data here. So now, and that has been saved there, transform data and orders. We can see that data is there. So now execute this partition one. So now we can see that it's save data here. So this time it's good. Now if we go here into files node and then refresh, first you check before refresh, you can see these files here. So now, because we would like to see a file with like in year and month. So transform data. Okay, let me go here. Where is that? Under file should be refresh. Oh, here. Yeah, after refresh that one, you can see that it has got partition data folder. And if you say it contains the year, and underneath here you can see those month. So first yearly, then inside there it's month. So it has been partitioned. So each month, and if you go inside, you can see all those like Parquet files there. So here you can see that one. Let's collapse that one. So now add a new cell to do a new data frame. We are just going to execute the order for 2021. So just to make sure that we are getting data only for 2021. So here we mention that here, and we also mention months. So it is ultimately using the partition table value, if I say. Now we are going to work with the tables in SQL. So far you see that we are using PySpark, Spark. Now cell. Now we are going to use Spark SQL library that supports the use of SQL statement to query tables in the metastore. So we are going to create a new table. Its format is delta and table name will be sales order, and get the table description is getting like from sales order. So if we execute the code, so here we did not specify any explicit path. So the files for this table will be managed by the metastore, and the table is saved in delta format, which adds relational database capabilities to tables. So now if you check here, ultimately it's giving the table level information. So this table has got these columns and what the data type of those columns, that you can get that information from here. So ultimately definition of the table, that we are getting information here. So now let's go to um, sales order table and load the data to Spark. So we get a new code like code cell, similar like to others. So execute that one. So we are getting those information from this delta sales order table. Ultimately, this is using SQL library. Now we'll run SQL code in a cell. Now here is the double percentage SQL. That is SQL magic, known as SQL magic. Beginning of the cell changes the language. So far, if you look, as you know, we are using PySpark, but this time when you use that one, look, it is becoming Spark SQL. So it's working as an SQL. So run the cell. So this is ultimately referencing the sales order table that we created previously. And ultimately we can query that data using SQL. Now we'll go with the visualized data with Spark. Charts help to see the patterns and trade faster than would be possible by scanning thousands of rows of data. So Fabric Notebook has got a built-in chart view. Uh, but for the complex chart view, we need to use um, other graphics, Python graphics like um, matplotlib or seaborn. So let's do some labs on that one. As we are going to getting the data to get, and here you can send that data, but there's an option called new chart. So you can get the data also chart format. So now if you go bottom, there's an option like you can editing You can also build your own chart. So select on build my own button, and there's the option like in basic and advanced. So for what kind of chart we are going to use for bar chart for this lab. Then for x-axis we can select item, y-axis quantity, then it has got legend, then series group we can leave blank, aggregation is sum. There are other operators. For this now we are going to use, and missing and null value display as 0, stacked is unselected. So we can see our chart here. So it's a new chart. So that is built in with notebook. Now we're going to use matter like a Python matplotlib. So if you execute this query, so this returns a Spark DataFrame um, containing the yearly revenue. If you look here, or yearly basis, so it's giving us yearly revenue and the orders, that you can see how many orders there and what the revenue. To visualize this one, we can use like chart. So for that, let use the matplotlib now, which is, oh, I'm getting connection issue. Let me reconnect again. Okay, here I am back. So let's new code block. So here we're using matplotlib and pandas. Because matplotlib needs pandas library also. So here you can see the nice um, chart format here. But definitely we can modify it more. Let's execute another query. Because there you see that no title for axis, or also for the chart title, but here we have used we got the title and also x-axis, y-axis. So here we have used that plot. So we have used matplot library and we input the pyplot. So it is much easier to understand. Let's execute another one. So here you can see that it can also give you the output for the figure size, which was not there before. So that's the difference here. So this also determines the shape and size of the plot. Now a figure can also contain multiple subplots on its own axis. So for that one, well, let's modify the code and execute. So it is that we are getting multiple plots here in different format. So now let's so while we use matplotlib enable so want to create a different chart types, it can require some complex code to achieve the best results. And for this region, mm, there are, there are new libraries have been built on matplotlib to abstract its complexity and enhance capabilities. And one such library is seaborn library. So let's use some um, with seaborn library. So we are using seaborn this time instead of matplotlib. And we can see the bar chart created using the seaborn library. Let's modify the code. It's like kind of more colorful that you can set that up. Different a few options there. So this time we are going to see the theme. See that the theme, you can modify that one. Now let's modify a little more. Now we are going to get as a line chart. So for this one, you can there are many documents you can go through and learn more on this matplotlib and seaborn. So we have successfully completed our lab. So always it's better to um, remove the workspace from your lab environment, because this is the lab environment. So you can always better to remove so that it will not charge when you are not using that one. So to go to workspace settings under general, down below remove workspace. So we have successfully completed this lab, and see you in next lab. Because a notebook is running, so I have to uh, close the notebook first, then we have to remove that workspace. So what I can do, so let me go to notebook. No, it's actually deleted because I cannot see any items here. If I go to my workspace, you can see it's nothing there. So it's deleted, but it was kind of messes in that window. Thank you. See you in next lab.